Here we want to compute the LU factorization and solve the system AX is equal to B. You can use any method you prefer, but I'm actually going to use the method I prefer, which is to use appended matrices. So when I do that, I'll look at the matrix that consists of A, which is -2, 1, 0, 6, -1, -1, 4, 2, -1, that has appended to it the vector B, 0, 6, 10. And I'm going to use Gauss transforms to find an upper triangular system and then solve it. So, first thing I'm going to do is look at the multipliers to zero out the entries 6 and 4. Well, 6 divided by -2 is -3, so the Gauss transform will have the entries +3, and 4 divided by -2 is -2, so this will be +2. And when I perform the multiplication, I end up with first row -2, 1, 0, 0. The second row, this entry will be 0. 3 times -2 plus 6. 3 times 1 plus -1 is +2. 3 times 0 plus -1 is -1. 3 times 0 plus 6 is 6. Then the last row will be 2 times -2 plus 4 is 0, like it should be. 2 times 1 plus 2 is 4. 2 times 0 minus 1 is -1. And 2 times 0 plus 10 is 10. So now I need to zero out this entry, which means the multiplier is going to be 4 divided by 4 divided by 2. So the Gauss transform will be 1, 0, 0, 0, 1, 0, 0, and then this entry will be a -2, 0. When I multiply by this, the first row will be -2, 1, 0, 0. Second row will be 0, 2, -1, 6. And then the last row will be 0. So it's going to be, this is 1. It's going to be -2 times 0 plus 0, -2 times 2 plus 4, which is 0, like we wanted it to be, -2 times -1, which is +2, plus -1 is +1, and then -2 times 6, which is -12, plus 10, which is -2. Okay, now I have my upper triangular system, which means that I'm trying to solve for chi0, chi1, chi2. I know that chi2 is equal to -2. I also know that 2 chi1 plus a negative chi2 has to be equal to 6 because of this row, which means the 2 chi1 plus 2 must be equal to 6. 2 chi 1 would have to be equal to 4, which means chi 1 must be equal to 2. And then from the first row, I know that negative 2 chi sub 0 plus chi 1 must be equal to 0, which means that negative 2 chi 0 plus 2 must be equal to 0, which means negative 2 chi 0 is equal to negative 2, and chi 0 must be equal to positive 1. I should go back and write out perhaps my system and check to see whether these will solve it. But the other thing I was supposed to do is to write out the LU factorization. Now I know what U is. It's the upper triangular matrix with these entries: negative 2, 1, 0, 0, 2, negative 1, 0, 0, 1. The lower triangular matrix I'm looking for is a unit lower triangular matrix, so I know at least the entries on the diagonals are all 1, and I know that the other upper triangular values are all zeros. So I need to figure out these 3 entries. They are found by looking at the multipliers. Now, our multiplier was negative 3 here, it was negative 2 here, and it was positive 2 here. So it's actually the entries in our lower triangular matrix are actually the negations of our Gauss transforms. And so these are my solutions.